3D printing and custom manufacturing on Mars. I'm Bruce Mackenzie. I've been active in the Mars Society since it started, also some other groups like NSS, SSI, and SEDS. I'm also the executive director of the Mars Foundation, not to be confused. We're pretty friendly, a lot of people, help out with both. And under the Mars Foundation, we are working on how to sell space and publicity for that. Well, how to sell on Mars. And the 3D printers are really hot now. It has greatly reduced the amount of equipment you would need to take into space in order to manufacture anything. So, and a lot of people have contributed. Some of the names are here, and you'll see some other names later. Okay, so a few years ago, we put together a team and designed a settlement and estimated the cost of, how much equipment you need to take to Mars in order to build a settlement. We chose 12 people, and then it would keep growing, another 12 every 2 years. Our launch cost estimate was 250 tons had to be sent to Mars. That was people, supplies, equipment, manufacturing stuff. And a fair number of those tons was manufacturing equipment. And then they would build this, and then they would keep on building. By the way, the estimated launch cost for sending, one of the NASA Design Reference missions had a similar estimate. For a program that would send 6 people to Mars and do it 3 times, came up with the same launch cost that we did for a permanent base. So half the cost of a round-trip Mars mission is the equipment and the supplies and the fuel to get you back. You can replace those return vehicles and equipment with manufacturing capability, and you can stay and you can grow, and it'll change history. So which has a bigger impact on the future, a growing Mars settlement or 3 round-trip missions? About the same cost. Here's another design, we are currently working with starting in a couple of weeks, we'll be working with a group of students at WPI in Massachusetts, and they will be working on an even smaller, cheaper one-way settlement plan. And there's another group working on an education project. I'd be happy to talk with you. Okay, so for the one-way settlement, we would send these modules in order. One of them is a chemical processing facility, and one is a laboratory or a workshop. And this is what it might look like. I have a cursor. Okay, so you might have a couple 3D printers here. You might have a water jet printer here, ink cutter, or a laser cutter. This is some kind of CNC machine. Here's some laptops, and this is an old-style drawing table because we needed more furniture to fill up the space. So, okay. The general plan for this would be minimal number of people on the surface, maybe 2, and they're named Eve and Adam. Go figure. You might have remote support from a crew exploring Phobos, but that's kind of beyond the scope of this talk. So you could send a chemical processing facility to make plastic and then have 3D printers, and maybe before people land, you try to test them out robotically. Anybody see this at the Dallas Mars Convention? It was made by kids, middle school or high school. They probably had help from their parents. You feed oxygen and hydrogen in here. We mix it. There's a catalyst here that produces methane and water. You condense out the water, and you're left with methane. So making...
There's a green pointer somewhere. This white thing right
okay.
towards me.
I'm afraid to use it. I think this advances slides. If you want to figure it out.
The center, that's in your hand there. There's a green thing over there. I don't know if that's the same.
Okay. Okay. Thank you. All right. So here you condense the water and you get out methane. So you can make fuel on Mars, and you don't need to be a rocket scientist. High school kids can do it with a little help. Okay. Now this is not all you need. You want to process the methane, or you want to make maybe ethylene and then convert it to polyethylene. It takes a number of chemical steps to make something like epoxy, but there are replacements for that. Polyester is almost as good for many purposes. Would you turn that off? Okay. I don't know. Okay. Frank Crossman did some studies for us about chemical processing. There will be a quiz at the end. Everybody's expected to know these formulas. Okay, but if you see things like, there's ethylene, you can make polyethylene. There's styrene, you can make a styrofoam cooler, if, you know. Another form of styrene is acrylic butyl styrene or something. I'm mispronouncing it badly, but that's ABS. It's what you make Legos out of. It's what the 3D printers typically produce. So basically, you can do the chemical processing on Mars. We have not we estimated the mass and energy and floor space to do it for the big hillside settlement. We want to redo that estimate for a much smaller settlement. And by the way, we are looking for people to help, you know, whether you know some branch of engineering, whether you're good at editing, drawing, want to do publicity, you know, let us know. Especially if you're working with a local chapter of the Mars Society or National Space Society. There are projects where you can build something and display them locally. Okay, we just got a partnership with Lulspot Company, Aleph Objects, the maker of the Lulspot. And they brought the printer that you saw on display. It's right outside the main ballroom. You can see it up till about 5 o'clock today. And one of the concepts is you can send this equipment to Mars and make more equipment. These are 3D printers where they manufacture the Lulspot equipment. These are continuously 24 hours, 7 days a week, are making plastic parts that will become part of the next printers that they manufacture. This particular model also uses a lot of aluminum struts. So a 3D printer can make many of the parts of a 3D printer. Also, laser jet and water jet cutters can make, you know, other parts. One of the first things you really want to build on Mars after you get there is greenhouses for growing food. That's going to be the biggest, you know, item that you need is greenhouses and food. And but we would like to, you know, come up with a project to make the little. Okay, I actually have them here. Okay, so here are parts of a 3D printer made on a 3D printer to become part of a 3D printer. Here are the gears for it. These are mortar supports. Do you want to pass these around? You can also see them on display later. You can make the valves, the fittings. You can make impellers and impeller housings for pumps. A lot of a hydroponic greenhouse could be made on 3D printers. You can extrude tubes and sheets. So these plant trays might be made of sheets of plastic made after you arrive. The corner fittings would be made on 3D printers, and then they'd be watered through pipes and valves that you make on site. Any quick comments on greenhouses? After a few years, you've built up a lot of biomass. You can start composting and, you know, mixing it with the soil. But
well, what I did notice at MDRS, not that I was on a crew, but how happy they would say we had a radish, whatever it was, that we grew
yeah.
on Mars, so to speak, and we ate it and it was good. It was such, you know.
By the way, we've been talking about sending a prototype greenhouse ahead of time and actually germinating the seeds just to make sure you can do it. Okay, kitchen. Here is a salt shaker. On Mars, it could be made from thin air. You don't need to bring it with you. Here's a beer bottle opener. I have trouble explaining to the kids. I do a lot of exhibit tables, you know, and I have these things out, and the kids come up and what's a beer bottle opener? Why do you need one on Mars? Okay, but imagine a lot of this kitchen equipment is made from something like acrylic sheet, you know, little custom objects. At high seas, they have a dishwasher and the little wheel that, you know, they have a tray of dishes to wheel in and out of the dishwasher, and the little wheel broke. They were able to print another wheel. So we have already had on-site repair at a Mars habitat with a 3D printer. They also broke their whisk for beating eggs. So Gene emails me and says, the crew broke their whisk. Well, a whisk is not mission critical, so they didn't bring a spare to Mars. And I said, well, so they said, could you design a whisk? And I said, well, yeah, but like I'm due at my relative's house for vacation in 8 hours. But I got on the internet, and there are open source designs for all kinds of CAD printed parts. And I typed in a whisk, and the first thing that popped up was, by the way, this is a piece of filament that goes into the 3D printers. And you could take several pieces of filament, bend them, print a handle, stick the filament in, glue it, and you had a whisk. We didn't test it, but I emailed them the link, and turns out they had internet restrictions, and they couldn't download it. So there's another quirk, another pothole on the way to space. But anyway, so we've already had a case of crowdsourcing a repair for a Mars hat. So somebody else designed a whisk, and it was crowdsourced. Okay. Any quick questions on greenhouses or kitchens or whatever? Yeah.
I've heard that 3D printers can be used to make metal parts.
Okay, yeah. There's many types of 3D printers. Let me hold that question. Remind me, please. Okay. What I'm talking about now is mostly the plastic extruders. In the background, if I get the right button, this is the inside of the high seas habitat. And they have just received this 3D printer. It's not the same one that from our sponsor. Here's a close-up view. There's a long reel of filament, plastic filament, and it feeds into here. This is basically a hot melt glue gun. It's got a motor to pull the filament in. It's got a little nozzle that heats it up and extrudes a very tiny thread of liquid polymer. And then, okay, one button. And this bed moves in one dimension, the head moves in another dimension, and it will draw one layer of your part. And you can, let's go ahead and pass these around. So you basically build it up layer by layer. How do you like the octopus? High seas in Hawaii needs their own octopus. And then after drawing one layer of the plastic, the head moves up, just like 0.5 millimeter or so. It's adjustable. And you build up, and you come up with a 3D printed part. The one that you see, sorry about the noise to the microphone. The 3D printer that you see in the lobby can print an object this big. This, I think this is 200 by 200 millimeters by 300, yeah, 300 by 300 by 200 millimeters. And you could make them larger.
How long did it take?
Quite a while, yeah. If you want a large object like this table, I'd recommend that you have an extruder that puts out something like acrylic sheet, and then a laser cutter to cut it. Now, by the way, the movement mechanism for the laser cutter could be made on a 3D printer. Okay, so you can bootstrap this manufacturing. This is a model of the high seas habitat. Is Gene still here? Yes, there you go. Gene, 1 hour ago, Gene told me this was emailed to me, so I added it to the slideshow back there. So, and you can see the layers up on top there. And here's their cargo container, and those are photocells, right? And solar panel. And okay, by the way, you can print it in different sizes. If you stop halfway, you can reach inside and see if there are little plastic people inside.
Do you anticipate printing the actual habitat?
No. Okay, there has been in the news, let's go to the moon and print a lunar, a lunar base. It could be done. There are more cost-effective ways to do it. Okay, so again, the small, complex objects on a 3D printer, the things this size on a sheet with a laser cutter. For the really big pressurized habitats, I would prefer something like fiberglass, maybe aluminum, maybe sheets of plastic. There are certain types of plastic that take the pressure very well. This comes out of our hillside study. My current suggestion is spun basalt, which is a little bit like fiberglass. So you scoop up sand and you dump it in a heater and you pull out filaments. And it could be held together with epoxy, but polyester is easier to make and almost, good enough. Yeah. I used to have a fiberglass kayak made with polyester. So you got to readapt your manufacturing techniques to fit the different cost and what's available. I've started telling kids, if you're going to go to Mars, you can choose one toy to take, and then the other toys will scan them, and you can have them waiting for you when you arrive on Mars, and they can be any size you want. Now the teddy bear won't be soft. That's another technology. Okay. Just in case people are enthusiastic about this and want to get involved, one of the things we'd like to do is get the word out that we can, with a little bit of equipment, start manufacturing on Mars. And one of the ways, I heard you mention that I give a lot of presentations, but if anybody wants to get involved with our WPI students, one of the possible things they might do is make a pretend Mars habitat. It might resemble this trailer, but instead of wheels, it would have rocket engines and landing legs and an aero shell. So anyway, you can buy a Mars habitat on eBay. It just looks like this before you adapt it. And we'd love to have one of these touring the country with a manufacturing lab inside it. That's the end of my prepared slides. I mentioned the box. Come on over to the lobby. They were printing one of these fancy things this morning, flower vase or pencil holder. You can take little mustache rings back to your kids. One other thing, if you ate downstairs yesterday or the day before, you could have ordered a baked potato, as I did, and the silverware is made from plant products. Someone thinks they're made from potatoes. So that's a little kind of incestuous, eating a baked potato with potato.
When you recycle it, you grow more potatoes.
Okay, there you go. By the way, one nice thing about Mars is you don't need 100% closure on your life support, because you can pump in more outside air and nitrogen. You can pump in carbon dioxide and nitrogen and argon from outside. You can pump in water. So unlike an asteroid, you can be a little less than 100% closure, and that would be a lot easier to get started. So I really think that Mars is the test bed for orbital settlement. We can give you little samples of filament. That part over there, would you hold up that blue part? That is a piece of an early model of a 3D printer. They've now replaced it with a metal part that is manufactured in larger quantities. So they made the early, you're going to be on camera. Sorry. So they made their early one in small quantities, printed, and then they switched to a more economical mass production. Yeah, questions? Yes.
So how do the 3D printed ABS parts react to vacuum?
I don't know, but I think they'd be okay. It's a normal plastic.
Are the air voids inside them a problem, or does it outgas quickly?
It is a problem if you're not careful. The different layers don't always stick together well. That's one of the modes of failure. So you got to get the temperature just right. But that's something we'd like to investigate. I think it won't be a problem. You might want to drop the pressure slowly and let them outgas. If you did not sign up on a sign-up sheet near the room, please leave me an address. So let's pass that around. Okay, just a minute. I also wanted to mention, we've been given a giant vacuum pump, and we don't have a use for it. So if you would like to find an organization that we can partner with that wants to run a program with like a vacuum chamber the size of this room, but all we have is the pump. Okay, it's a 4 kilowatt pump. It can go way below Mars pressure. It evacuates 2 cubic meters per minute, I think. It's a roughing pump for big physics experiments. But there's an example of how, things can happen and they don't have to be governed.
So what are the advances that you foresee in 3D printing in the next 10 years?
Oh, advances. That reminds me of your question. First of all, is the next speaker here? Please come up and start setting up. Next speaker, raise your hand. Yeah, come up, start coming up. Okay, advances in the next few years. Let's try to get back on schedule. Okay, first of all, I forgot to answer this question, sir, about different types of printers. I've been talking about the extrusion of plastic. There are also printers that print in powder. One of the first well-known was by a company called Z-Corp. They printed with gypsum or plaster powder mixed with a little bit of cornstarch. These were not very strong, but they were fast and very flexible, and you could fit the parts together for testing. There's other kinds that do metal dust. So you glue together layer after layer of metal dust, and then you sinter it. I don't know the exact details. There's some kind of printer that will do artificial teeth. I don't know the material.
I used to think nowadays, they directly laser.
Yeah, right. Okay. Yeah, so he was reminding me, there's a laser sinter that will sinter the metal dust. There's a beautiful YouTube video of a guy sintering the sand in the Sahara Desert and making a bowl. You can use this beer bottle opener is not made from petroleum or ABS. It's made from polylactic acid. Gene can tell you about it. And it's made from corn. So, if you don't want to do one specific type of chemical processing, you can grow corn and do it that way. Last question, I think. Yeah.
ABS and fuel, which one better to bring or which one?
What we want to do is manufacture the raw material after we get there. Okay. Now you want to do a little bit of testing first. ABS is the common one. Everybody's using it. It's cheaper, but polylactic acid is almost as good. A little more expensive. You can also print in nylon. There's a mixture of wood and styrene that you can print with that looks like wood. There's a new material I only heard of this morning. I don't remember the name. Does anybody else know of a new material?
It's not yoga. Yoga?
I don't think so. Okay. Please sign up on that sign-up sheet. Come by and look at our printer. Should I keep talking, or?
No, we're just about ready.
Yeah, well, please interrupt as soon as you are. Is there another question?
Just say Friday, and I just be
Yes. Question?
Have you looked into getting a metal printer or a powder printer, basically?
No, we have not. What we want to do is the top level design of the Mars settlement, make sure every step can be done, and publicize it. So we're more interested in that kind of stuff, and we don't need to test it ourselves. Okay. No.